In this exercise, we're being asked to graph the function f of x equals the absolute value of x. This is also known as the absolute value function. Again, to graph, the process is the same. We find points and determine what points go on our graph, and then we connect the points with a smooth curve. So in this case, f of x equals the absolute value of x. So we plug in, I went ahead and made a chart here from -3 to 3 for our x values. So f of -3 equals the absolute value of -3, which equals 3. F of -2 equals the absolute value of -2, which equals 2. And you'll notice a pattern here fairly quickly if you haven't already. F of -1 equals the absolute value of -1, which equals 1. The absolute value of 0 is 0. Absolute value of 1 is 1. Absolute value of 2 is 2, and the absolute value of 3 is 3. Fill in our table here. Our points will be -3, 3, -2, 2, -1, 1, 0, 0, 1, 1, 2, 2, and 3, 3. So we plot those points, -3, 3, -2, 2, -1, 1, 0, 0, 1, 1, 2, 2, and 3, 3. Now we're not going to go below 0 because an absolute value is never negative. So essentially we are just connecting the dots in both directions going up. And what you should notice is that this is basically just the line in the negative direction, y equals -x, and in the positive direction it's y equals x. Well, that makes sense, since if we're solving for the absolute value of x, remember we have to do the positive and the negative because it's looking at distance. Each one of these lines represents the distance from 0 on both sides of the y-axis. So again, this is the absolute value function. F of x equals the absolute value of x. We just kind of discussed this in a roundabout way. The domain would be -infinity to infinity. It's not restricted. You can put in any x value you want. And then the range, it can only go down to 0. It won't go below 0 because absolute value is never negative. So it can include 0. So we put a square bracket for our interval for the range. And again, it goes up infinitely, so our right endpoint would be infinity.